It is now my pleasure to introduce this morning's opening session. My colleague, Amy O'Connor, leads Cloudera's team of vertical industry and subject matter experts, principal architects, and business value consultants. She advises customers globally as they introduce big data solutions and adopt enterprise-wide big data delivery. She was recently named by Information Management as one of the 10 big data experts to know. As a sought-after industry leader and thought leader, Amy has an extensive background in the Hadoop ecosystem, in building big data skills and teams, and in developing business-focused analytics use cases. Amy's session will examine machine learning, artificial intelligence, and the future of big data analytics, and how these emerging strategies can enable data-driven insights for agencies and organizations to operate more efficiently, manage risk effectively, and enable and transform the public sector. Amy, the floor is yours.
Thanks, Christine. Good morning. I'm very happy to be here in snowy Denver. Thanks a lot. I'm from Boston, but we haven't seen the white stuff yet, so it was a little scary when I got up this morning, although a little bit less than what folks had said. So I'm going to talk to you this morning about some of what Cloudera can do to help you and your agencies, the work that you do to bring new experiences to citizens, to help run agencies more efficiently, and to help protect assets. So I think the first thing I want to just talk about is we have been in this world of big data now for almost a decade. Hadoop was originally invented by Google, who wrote a bunch of papers on it. The work was written by Doug Cutting at Yahoo, who is our chief architect at Cloudera. He put all that work out in open source. And from there, we've developed a whole industry around it. And I want to show you what some folks are doing today with big data and some of the opportunities that you have. But I thought I would kind of start with a little bit of a level set, because sometimes when you read the trade rags and you pick up the newspaper, it looks like, wow, everybody's got artificial intelligence running everywhere. Am I a little bit behind? And the fact of the matter is that, this is from the Harvard Business Review just this year in 2017, that some of what you read is just kind of the bleeding edge. We're going to be on this journey with using data differently over the course of the next few decades. That's how long transformations tend to take. But if you look at some of these numbers, I mean, right today, even when we talk about structured data, which we've all had in our hands for decades, less than 50% of that is even used today to make decisions. When we look at unstructured data, whether it's video or audio or any sorts of new types of sensor data that might be coming in, less than 1% is being used around the globe today to make decisions. This is a scary one. As we start to make data more available to people, a lot of the appropriate security controls aren't in place, and so 50% of employees have access to data that they shouldn't. And that's something that really has to get addressed in order for us to take advantage of the data that we have at our hands. And then finally, you probably hear this all the time, you probably hear it within your organizations, but people want to use data to do things differently, and they're spending the majority of their time just getting the data in and getting it in the right form. So there's still an awful lot of work to be done here. We're really still kind of at the early adopter phase, and we're going to see our world continue to change with respect to data over the course of the next couple decades. And that's actually why The Economist recently published this article that talks about the new data economy. We firmly believe that we're going to start to see data show up as an asset on company balance sheets. If you look at the most data-driven companies in the world, whether it's Amazon, Apple, Google, their market capitalization grew 476% over the course of the past few years. That's 7 times faster than the market as a whole has grown, which basically says there's an incredible asset in there to be used. And when you look at it as well, IDC talks about just how fast is that asset growing. Amazing numbers like by the year 2020, we're going to have 440 times more data available to us to be used than we have today. There are going to be 30 billion connected devices. By the way, did anyone else go into the lavatories here, and when you put your hands under the sink, it plays row, row, row your boat? You talk about sensors, right? Interesting little experience there. And a total market cap of people spending money on data and analytics services to the tune of $200 billion. And that all is enabled by some new technologies. It's enabled by cloud, the ability to start to make decisions as to what's the hardware you're going to use underneath this and where is it going to be available to you. It's enabled by open source software. Over the course of the past 2 decades, we've seen the proliferation of open source software and have all come to understand the advantages we gain from it by having communities of people contributing to this open source, which means that the innovation grows faster and faster. And then also, we're going to talk a little bit about machine learning and the idea that you have a lot more data at hand. So instead of doing analysis with samples of data with simple statistical methods, you can now let the machines have at the data to make decisions in new and different ways. So I have to ask you guys a question. How many of you sleep with your mobile phones? Okay, now let me ask you another question. How many of you are lying? All right. Usually in an audience like this, people say to me, how close does it have to be to me to count that I'm sleeping with it? How about, how many of you sleep with it within arm's length? Okay, I do too. And actually, sometimes it does end up under my pillow, which I know is really not a good thing, especially any of the health people in the room would tell me that. We sleep with our phones. I sleep with my phone because when I get up in the morning, I actually want to know what's the weather going to be like. Did it really snow? What am I going to wear? What's my schedule look like? What do I need to be prepared for? What happened in the world since I went to sleep? What's been going on, because we live in a rapidly changing world. And then after I read all that and get kind of stressed out before I even take my head off the pillow, I open up my meditation app so I can do a little meditation and get myself prepared for the day. I mean, fundamentally, we sleep with our phones because of data. It's no longer there to make a phone call. I can't remember the last time I was lying in bed with my head on the pillow and I called someone. No, I sleep with that phone because I am used to and accustomed to the data that it gives me to help me inform what I'm going to be doing for the day. So, and that kind of brings me to Cloudera. What do we do at Cloudera? So we kind of start with this premise that we do believe that data is going to make what's impossible today possible tomorrow. And we start with the most out-of-the-world use case that I could possibly think of, and it's NASA and the Orion spacecraft mission. So they've instrumented the Orion spacecraft with a lot of telemetries and sensors, so that what they can basically do in the first Orion mission is they take all the data from it. They can actually see that the mission generated 80% of the velocity that a return from the moon would generate, so they can make simulations that actually can predict what's going to happen in different types of missions going forward. The current Orion mission is going to last 4 times as long, produce many, many petabytes of data. It has instrumented on it a lot of equipment that will sustain life. And so the way that we kind of look at this particular area of use cases is we're helping NASA and the Orion spacecraft to be able to eventually get people to Mars, but more importantly, to bring those people back home. And that's kind of our most out-of-the-world use case that I can explain to you. But when we kind of talk with companies and agencies and governments around the world, the work that people are doing fall into these 3 buckets. The first is really understanding people better. So using data to understand what people's expectations are in order to make their experiences better. Using data, in the second case, to build connected products and services. There's a lot of talk about smart cities. We work with a couple of folks who are working on smart airports. I just came through the Denver airport yesterday. I think there may be some folks here from the Denver airport, but quite an amazing airport. And I can only imagine how much more it will change over the course of the next few years as it gets instrumented more and more with sensors in order to make my experience going through that, you guys call it the mile-high city, I call that the mile-wide airport. Holy cow, you got to walk a long way in that airport. But in order to make my experience a little bit better going through that airport. And then the third area that we all face all the time, because unfortunately most of us have had a personal experience already with respect to data breaches. And so in order to be able to protect assets, one of the biggest assets you have is data. And so we see a lot of work being done in the area of cybersecurity and in compliance, regulatory compliance, and just in risk management in general. We do this in a couple different ways. I talked about open source earlier. we take an open source platform out of the Apache community at Cloudera, and we wrap it up into a distribution so that we fully test it. Not only that, we run Cloudera on Cloudera, so before we release the next version to the market, we're already running our own company on it. That's the first piece. We focused a lot on enterprise grade in that space. Scalable. So this original system, based upon some of the work Google did, was all about scale. It was about economies of scale. It was about parallel processing. It was about being able to do things at scale that you never could before. And then finally, being able to run anywhere. All of our environments are changing drastically, whether it's at work, whether it's across different agencies, or even in our own personal life, as to what do we continue to store in physical devices that we control versus what we store somewhere in a managed service or in more of a cloud environment. We've seen a lot emerge in the course of the past couple years in this area of machine learning and advanced analytics. When we think about this, up until 8 or 10 years ago, a lot of analysis was done with traditional statistical methods. And one of the first things that we all learned in stats was to pick your sample. And you had to focus a lot on bias and making sure that you had a good sample. Well, now what you can do is you can do analysis against the full population of data. And when you can do analysis against the full population of data, it means that you can apply whole new analytical methods to that analysis. So a lot of work is being done in the area of machine learning. In machine learning, it's everything from pattern recognition, being able to kind of point your machines at these big sets of data and let them figure out patterns, whether it's k-means clustering. So, in the market research world, no longer manually forcing market segmentation, but actually letting the data speak for itself to create affinities among people to identify those segments. Anomaly detection, I mentioned cybersecurity, but everything kind of around time and space works well in this case, geo-positioning. So is someone somewhere right now where you could offer them a service because you recognize what's happening? Is this behavior that someone's exhibiting something that's different that could indicate fraudulent behavior? And then finally, just prediction. So knowing what people have done in the past, knowing what people like them have done, understanding networks better, will enable you to predict much more what people expect and really want in the future, which will create tremendous efficiencies as well as citizen satisfaction. But that doesn't take away from the fact that people are still doing standard analytics. So people are still doing self-serve business intelligence. But now they can make the full set of data available to their constituent base and let them run tools, traditional tools that you already have in your hands against very, very large sets of data. Real-time analytics, this is an interesting one. So while you maybe have built a dashboard that explains things that have happened in the past, you might also want to understand, well, there's a bunch of data that's streaming in. Is there anything that indicates that there's something happening in that right now that's a little bit different? So this system that we have enables you to do some real-time analytics as well. And then also secure reporting. Security is just a huge area of focus. So I'll take a step back. Cloudera at a glance. Our company was founded in 2008 by folks that came from Oracle, Facebook, Google, and Yahoo. And what they all recognized was they were working in this world of big data in those 4 companies, and they basically said, wow, what we're doing could be used by anyone, in any industry, in any government, in any place in the world. And that's the basic premise upon which our company was founded. The second number, I think, is a sort of a strange number. Where we have 1,600 employees, but we have 3,000 partners. That's a little odd, right? Most startup-y kind of companies struggle to get a couple people to sign up to the partner ecosystem. To me, that number is a representation that the entire IT industry understands that we're going through a transformation. And so basically, everybody out there jumped on the bandwagon. Now, our account teams can help you guys figure out which partners can help you the most, because some are integrated more than others. But that is an indication that the IT industry is basically saying, you know what? Everybody's going towards this big data, using data and analytics, doing machine learning. And so I better make sure that I'm some sort of legacy IT company or a new IT company with some sort of tooling or services that I'm heading in that direction. And then finally, just in our own customer base, we are the largest kind of big data company out there. We have our customer growth over the last 4 years has been 48%. But more interesting is that individual customers, our largest ones, are expanding at 40% a year. So that means that wherever they start, the next year, they bring on 40% more capacity in order to continue to do analytics. So if you think about it, it's kind of cool from our business model perspective. It just means, we start working with people, the success and the return on investment is so evident that they just move right to the next step and continue to expand their environments. By the way, our largest customer, is along the lines of 300 or so petabytes of data under management with several tens of thousands of nodes managing this data. A lot of the things that we all do on a daily basis, a lot of the things that I mentioned that I do before I even get out of bed in the morning, look at my phone, are all running on Cloudera underneath. And that, this kind of just shows you in those industry verticals, 7 out of 10 of the top financial services companies in the world are running on Cloudera. A lot of the exchanges are running on Cloudera. 9 out of 10 of the top global telcos are using the Cloudera data to manage their networks, to manage their relationships with people. 27 countries, their governments are using Cloudera. Everything from sort of the more sexy things like smart city initiatives that are just starting to kick off to a lot of work in tax offices, as you can only imagine. 6 out of 10 of the top healthcare companies are working with Cloudera. We expect to see a tremendous rise in that space as the population of our world continues to increase, and we need to honestly, come up with better economies of scale as to how we deal with healthcare. Then finally, 8 out of 10 of the top technology companies are running on Cloudera because the technology that we have in our hands is all based upon data. So I'll give you a few more examples here. On the state of Ohio, they recently built a platform, platform as a service for a whole bunch of their agencies. And so what they decided to do was, instead of having individual agencies go out and build their own big data platforms, they said, we should be sharing data across those. So they invested in this platform as a service. They have 21 agencies on board now. They offer the platform itself. They offer training to the folks in those agencies. They offer support services to the folks in those agencies. And then probably most importantly, they offer data, and they offer insights, and they offer visualizations. So they've really created a great community in the state of Ohio around the various different agencies, and have been able to build out a platform that's 1/10 of the cost of what it would have taken the individual agencies to build their own pieces by themselves. So Kentucky, we talked about snow here this morning, and Kentucky, I think, doesn't usually get a lot of snow, but in the 2013-2014 season, they really were hit by a lot of snow. They instrumented a lot of their equipment with sensors so that they could have an understanding as to which roads had they cleared, where were there accidents, what was actually happening in the space. They were able to, this is data that they used to process in a traditional database system, and it would take them 3 to 4 days to process it after the fact to figure out what happened during storms. And now they're able to actually process the data during storm systems. Within 3 hours of a storm, they're able to do some predictions on roads and roadways that are going to need maintenance coming up. And they were able to conform to some federal mandates that enabled them to be able to report out as to some of the things that they were doing. They also did a couple other interesting things, is they created connections to Waze and Twitter, because they said, now we understand a lot more as to the state of our roadways in Kentucky during storm systems, so we should be sharing that information with our citizens. So they report back to Waze, so you can now go on Waze and actually see which roads have been cleared or not. And they report back to Twitter so people can get an understanding there's an accident here, this road's been cleared. So it's been a really good communication mechanism as well. And we're seeing a big increase in people in the agricultural industry starting to work with data in new and different ways. We have to feed a lot of people on this planet. The agricultural industry is under tremendous pressure, needs to get some new economies of scales, needs to get a lot more innovation. So there's one of the major U.S. agricultural agencies is doing work in this space, but their first foray into this was around cybersecurity. They realized that they needed to protect the most valuable assets out there. So they implemented a system using a lot of the access that people had to data to really look for those anomalies. But we're also working with a lot of agricultural companies that are starting to basically say, you know, they're managing fuel, they're managing the distribution of seeds, they're managing the understanding of the interaction of weather. They can use satellite images. So there's a lot that's happening in the agricultural space, which is going to enable us to kind of better manage an incredibly important resource on this planet. So what is this Cloudera thing? You know, it's not a relational database. It's a lot of things. Maybe I should use a Swiss Army knife, but a really good Swiss Army knife analogy here. So on top of this system that we built, and the core of it is based upon open source, and we've done a lot of innovation around it to make it more performant and more secure and more easily managed. But on top of this system, you can do all sorts of things. You can do some new data science types of applications where you're really posing a hypothesis and looking for an answer by using different analytical methods. You can do traditional SQL types of queries, but you can do SQL types of queries against petabytes of data. You can build applications, the ones that we talked about that run on your phone that are like low latency type of app. You want your answer right away. You're not going to lay in bed and wait 3 seconds for that screen to refresh. You want to know what's going on right now. So you can have an analytical system that returns results in a very low latency way to those applications that are live on mobile and web properties. You can do that data engineering, which is those 80% of the work still needs to be done on cleaning up the data and getting it to be better. So there's an awful lot of tools inside the system that let you do ETL processing in much better ways. This is all based upon what we call our shared data experience, which is a lot of the services that we've built underneath all of those engines that run on top. And all of those engines share the same model underneath. And that model underneath consists of unified security. So one of our largest investors at Cloudera is Intel. They actually invested over $700 million with us back a few years ago. We do a lot of work with them on security. So when we are building more things with respect to encryption, for example, Intel is now working to push some of that stuff down into the chipset. So we're very focused on security in the areas of authentication and access control and encryption, so that you can be ensured that, my earlier slide said a whole 50% of people or 70% of people have access to data that they shouldn't. You can be ensured in the system that you will be able to control that, and you'll be able to monitor it and audit it so that you know what the data is only being used appropriately. Consistent governance, the same types of things, tracking lineage of data as it flows through a system and gets changed and then used in a particular application. Is that the appropriate use of data? Do you know how it was transformed along the way? Easy workload management. I talked about data science and SQL and low latency applications. Well, we've got tools that enable you to really manage all those different types of workloads so that you know that the resources are allocated the appropriate way as best your agency needs to work with them. Fast ingest and replication. If you can't get the data in, you can't use it. We've got a whole bunch of tools around being able to ingest data from all sorts of different places in the world, and then let you replicate that data as is needed for protection or for access in different places. And then finally, a shared catalog, the ability, if you can't document it and tell people what this data is, then they're not going to be able to use it. So between the tools that we provide and a lot of tools that come from that partner ecosystem, there's a whole bunch of things that you can do to make this easier. So I want to just go back and mention the cloud a little bit. We have built a lot of tools that enable you to move easily between on-prem and in the cloud. And depending upon who we're talking in what industry, there's different requirements. Depending upon your workloads, there's going to be different requirements. We expect over the next decade for people to move some things to the cloud. We see data originate in the cloud when applications are running there. Yet we also see a great need for people to continue to run in their own data centers or in data centers of their partners. So we offer tools that enable it very simply for you to spin up these types of environments to run different workloads in all sorts of different places. We support hybrid. You can have some of it in very different public cloud environments. You can have some of this in your own data center or in managed services centers. And also, all of those enterprise tools that I mentioned earlier, the focus on scale, the focus on security are implemented in our cloud and on-prem environments. So I'm going to hit on a couple things because I talked about going to Mars, and you might be thinking, that's actually not my first use case. That wasn't NASA's first use case either. So going to Mars is kind of cool, and being able to be involved in that is cool. But quite frankly, the majority of our customers today are working on use cases that provide more visibility into their business, into the services that they provide, using more data to understand the past. And that's what we kind of call this visibility part. This is where you're starting with just a lot more data. You're maybe using SQL. Maybe it's more well-structured data. And you're able to augment some of the things you already know so that people can have deeper insights into what's already happened. And where that takes you next is the ability, once you understand what's already happened, to start applying some new models to basically say what could happen next, get towards predictive, be able to hand some of these tools to your users so that they can serve themselves to pose hypotheses to see what might happen next. And finally, getting to those truly world transformative use cases, the ones where, sure, we're going to Mars, but also where we're instrumenting cities so that they can handle the very large population of people that live in those cities and ensure that we understand whether there are health problems that are caused by certain parts of cities. We can understand safety. We can better manage transportation. And we see this across all of our customers, that this isn't technology. There's a lot of really cool technology I've talked about, but the success here comes from you guys. It comes from leadership. It comes from people doing certain things well. And these are the 5 things that we've seen our most successful customers do. The first thing is they build a data-driven culture. And what that means is that people start talking about data more than results. What data do we have? What data could we generate? What data could the Denver airport tell us? And when you start thinking about it that way, you can come up with whole new ideas. When you have the right folks who are advocating for data, who are building visualizations of what you've already found, it propagates on itself and starts to build a community, like in the state of Ohio, where people are starting to share more. The second piece is the right team and skills. Quite frankly, a lot of the skill sets that we built up in IT over the past 2 decades don't exactly apply here. We're talking about unstructured data. We're talking about collecting data that you could pose a hypothesis on before you even know exactly what you're trying to produce. We're talking about producing results that can be fed directly out into mobile and web and enterprise applications. Requires some new skill sets. The third area is just becoming more agile and lean. This idea of posing a hypothesis, kind of means you don't want to pose a hypothesis and then work on it for 18 months and prove it wrong. You want to pose a hypothesis and work on it for 2 to 4 weeks and prove it either directionally correct or not, so you can make that type of adjustment. So there's a lot that's been written in this space and a lot that we can do to help you to kind of get a better understanding as to how to become agile and lean in your approach. Leveraging the ability to use DevOps for production. So this is something that happened in the web world for a long time. You're agile and lean in your development, and then on the other side, you have a data center, and you've got folks who basically say, I can't deploy what you just built. We haven't gone through a 6-month testing cycle. So there's a lot of principles that have been used in web development that are now starting to be used in the world of data. And then finally, right-sizing data governance. It's another concept of, instead of understanding everything about all your data before you start to use it, becoming more iterative in nature and letting power users have access to a whole bunch of data, but they can explore it and find insights in it, but they can't connect to the outside world and put anything into production. So right-sizing your data governance so that the controls are a little bit looser up front and get much more stringent as you get down to production. Some of these concepts are almost taking what we've done in the traditional database world and turning them a little bit inside out. So there's a couple places that we at Cloudera can help you here. We've got Cloudera University, a bunch of training. A lot of our partners do training as well. When we talk about the right team and skills, training is absolutely essential. We've got a professional services organization. We have a whole bunch of system integrators partners that can help you with anything from getting your cluster environments, your cloud environments up and running, all the way up through data ingest and starting to do some of your initial use cases. And then finally, we have a support organization, And it's a proactive and predictive support organization. So what we do is we ingest the configurations of our customers' clusters. Not your data, but just how did you configure your cluster environments. We run machine learning algorithms against those. And in the past year, we've opened about 10% of our cases, our customer cases, to basically say, we found that you may have a configuration issue that we found in another site. And if you change your configuration, then you're going to get much better performance. So our own support organization is both proactive and predictive in how we use data that comes from our customer environments to help you to have environments that run much better. And I'll close there. Our platform, as I mentioned, it's very different. We kind of call it the modern platform. The open partner ecosystem that we can help you navigate through means that a lot of the tools you're already using will work in this ecosystem. They can now just attach to this new system and do various different things. And I think I showed you some proven success. So while we're not at that point where everybody's sending people to Mars, we are at that point where many, many businesses and governments around the world are using data and advanced analytics and machine learning to offer whole new experiences to our citizens, our constituents, and our customers around the world. Thank you.